Hello, and in today's video we're going to look at fractional distillation, which looks at separating crude oil and how we can do that. If you haven't already, I would recommend looking at the crude oil video because that explains what crude oil is and some of the specific parts of crude oil that are really important for this. I'm going to start off by going through three properties of longer and short chain hydrocarbons, because that's really important in the separating of those hydrocarbons. So these are the three I'm going to focus on: boiling point, viscosity and flammability. They're all important for the AQA specification, but the one that's going to be really important for fractional distillation today is the boiling point. So first of all, what is boiling point? Well, it's the temperature, the degrees at which it becomes a liquid becomes a gas. So it's when it goes from that state of being a liquid into a gas. And I'm just going to look at the methane to start with, which is a really short chain. And what I mean by short chain is it's only got one carbon, and therefore it's only short. And in methane, we've got a low boiling point because of that. Because it's a short chain, it's low boiling point. Now, butane is a slightly longer chain, still quite short, but it's got 4 carbons in that alkane. So it's a bit longer. So it's going to have a higher boiling point because it requires more energy for it to go from a liquid to a gas. Now, the next property we're going to look at is viscosity. And that word isn't as common in science. I don't think we use it as much. It's how runny something is. So it's looking at how easily it flows and things like that. So viscosity in methane, where it's only a short chain, it's a very low viscosity, which means it is very runny. Whereas when we're looking at a longer chain where there's lots of carbons in that chain, it's going to be a high viscosity. So it's going to be higher the longer the chain. So butane's not the longest chain, so I can't say the highest one. It's the higher than methane. So it's a higher viscosity, so therefore it's going to be thicker. So it won't be as runny as methane. Flammability, and that's how easily something burns. And the shorter the chain, the more flammable it is. So this one is this methane, which is a very short chain, it's only got 1 carbon, is very flammable. It will burn very, very easily. Whereas if we go to our butane in the red, where it's longer chains, it's not the longest, remember, you would have a less flammable. Not the least flammable, it's just not as flammable as methane, so it won't burn as easily. Like I said at the start, the most important one to understand fractional distillation is our boiling point, because we need to remember that methane, which is short-chained, has a very low boiling point, so it's going to become a gas at a very low temperature. At that same low temperature, the gas will become a liquid, so it will go the opposite way as well. And that's really important. That point at which it becomes a liquid into a gas, or a gas into a liquid, is low temperature, whereas for our high boiling point, for our high-chained, long-chained molecules, it's going to turn into a liquid from a gas at a higher boiling point, higher temperature, as well as the liquid becoming a gas at a higher temperature. And that will help us in fractional distillation. So what is fractional distillation? So now we know a bit about properties of these alkanes, I can tell you what it is. It's the separation of the molecules in crude oil. Now, how do we do that? How do we do the separation of molecules in crude oil, it's through this process called fractional distillation. And there's two main steps to it, two processes that happen that you will have seen in science multiple times before. The final stage is something a little bit different, but we will be able to work it out. So, crude oil, here we've got different shapes representing the crude oil, and I've just put that there just to kind of show us what crude oil is. I could go over and label this one as methane and this one as C2H6 if I wanted to. I'm not going to label them all, but it's basically saying fractional distillation. I'm going to separate all these things out. So we're going to do it through two processes. First process is evaporation. So I'm just going to remind you of what that is. So if we draw a particle diagram, two boxes with the particles in it, we're going to start with a liquid. So the particles would all be connected in a random organisation, and it's going to become a gas where those particles are free to move and are not touching. So that's the first process of fractional distillation. The second one is condensation. Now, what is condensation? Well, it's actually when we go from a gas into a liquid. So it's the opposite way around. The particles are free to move. They're then cooled down into a liquid, where the particles are randomly arranged, but they're all touching each other. Now, if you might be thinking, well, if I've got a liquid, like crude oil, darkish liquid, and I was to heat it up and then straight away cool it back down, condense it back into that liquid, I would have the same molecules to start with. I'd have that mixture of hydrocarbons. I would not have done anything. And that's the reason that it doesn't happen like that in fractional distillation, is this star point. So the two processes are evaporation and condensation. The star point is the different part where all the different molecules separate out based on their boiling point. They separate out based on their boiling point, and that is key because we know that longer chains have higher boiling points, so we can use that to separate it out. So we use different boiling points to separate out based on chain length. Now the equipment we use looks a bit like this, a little bit different, never used it before. We'll start off with the crude oil entering a heater. That is where our first process of evaporation happens. So our crude oil is heated up from a liquid into a gas. So it becomes a gas quite early on. I'm going to just jump the star part because this is where the star happens. And I'm just going to jump to our process 2, which is condensation. Now condensation happens in all of these tubes that are coming off of here. So here, all of these tubes where the condensation is happening, and that's where the gas goes into a liquid. So we've seen the two processes that we know. Now how does that the crude oil separate? Now here it's really, really hot, and I've just coloured this in to show representation of heat. Really hot at the bottom and colder at the top. So it's cooler at the top, warmer at the bottom. And that's just because this bit's closer to the heater, whereas this one's further away from the heater. So our liquid crude oil is heated up until it's a gas. The gas enters this fraction column, is what we call it, the column. When it enters the column, the gas separates depending on its chain length. Short chains go to the top, whereas long chains are at the bottom. So things like CH4 would be at the top, whereas at the bottom you'd have something like C20H whatever, depending on whether it's an alkane or an alkene. So the shorter chains, because they've got a lower boiling point, they will turn from a gas back into a liquid, so they'll condense at a lower temperature. So they travel further up the column before condensing back into a liquid. Whereas our longer chains, so let's draw it like this, really long chains, well, they'll become a liquid in really hot temperatures because they need even hotter temperatures to be a gas. So our long chains will leave at a hot temperature, whereas those shorter chains, particles, will leave at the cooler temperatures because they don't need as much energy to become a liquid. So it means that it takes them further up the column. So shorter chains are at the top, longer chains at the bottom. And it's all to do with the fact that the cooler temperatures at the top, so that's where the shorter chains are because they've got lower boiling points, whereas our hotter temperatures at the bottom are because of those longer chains, which means that they're going to have higher boiling points. So just to recover this again, evaporation happens as the first step, liquid to a gas, and then the particles, the molecules that are all mixed together as gases come into the column. They separate based on their boiling points, and this means that the shorter chains go out at the top, whereas our longer chains leave at the hotter temperatures because they've got higher boiling points. At this point, it's condensed into a liquid, and the liquid is collected in beakers or whatever at these points that they are leaving. So we've now got A, B, C and D separated out. So at the beginning, A, B and C were mixed together in a liquid form, and we've separated them out over here.